One of the typical questions that I might ask you to do at the end, at closer to the end of the semester, which involves a lot of these quadratic equation solving stuff. So suppose that we have a chemical reaction. HA turns into H plus and A minus, and they're all in equilibrium. And we also know that the equilibrium constant is 10 to the negative 4. So it's not on the class planner. It might be in some of the last pages or so, but I'm adding it in just for context. So initially we have a 1 molar solutions of HA. So we have 1 molar here, and we have no H plus. And I'm going to get rid of the molar just for simplicity, just to make it easier to see. And the last one is we have 0.2 molar of A minus. So what happens, what is the concentration of H plus at equilibrium? Well, you cannot have, at equilibrium, essentially you always have all of the species all at the same time. It might be a very tiny, tiny bit, but there's always a tiny bit. And that's what we're going to try to find out. So suppose that we have a chemical reaction that goes like this. Well, we have none of this guy, so in order to increase the entropy or the randomness, we have to create some more of H plus because we started with 0 initially. So the change is going to be minus x for our HA. Our H plus is going to increase by the value of x. And for now, all the stoichiometry is just 1, 1, and 1, so it's pretty easy. And the last one is that A minus is also going to increase by a value of plus x. So at the end, excuse me, that's not I. So it's an I stable. Initial change and E at the end is equilibrium. At equilibrium, we have the concentration of HA would be 1 minus x. H plus is going to be x. And then A minus is going to be 0.2 minus plus x. So that's our condition at equilibrium. And because we know the equilibrium constant is 10 to the negative 4, we can then try to solve for x. We want to know what is the concentration of all the species at the very, very end. And hopefully you can see on that summary page that it looks exactly what you've just done before. So we know that at equilibrium, this whole thing is going to be equal. The concentration, as you multiply and divide, is going to be equal to the equilibrium constant. And I'm going to be a bit lazy and just going to write down the concentration of H plus. As long as our unit is in molar, we're okay. This is A minus divided by concentration of HA. So this is going to be true at equilibrium. That the equilibrium constant is concentration of our product divided by a reactant to the power of their stoichiometry. And the stoichiometry is just 1, 1, and 1. From here to here is okay, right? Here, the reason that we're adding H plus here is because initially we have none, and at equilibrium, if we put a value of 0 here, our equilibrium constant is not going to be 10 to the negative 4. It's going to be 0. So there must be an x amount left. So we're